This is just a preview for the next part of my adventure with Minelab coils. So the 19-inch now is exposed. I've got the connections to the transmit and receive coils free, so I can do some measurements. Now, I have an LCR meter. This one will pick up the inductance, resistance of the coil, and it only operates up to 100 kilohertz. So I've checked its values from as low as 100 hertz right up to 100 kilohertz. So I've got an idea of the transmit coil impedance at this stage. I also have here this lovely old piece of gear, which is an RCL bridge. This will allow me to then confirm the inductance. We have a lab supply here. This one is a function generator, and so we have an RF generator and a function generator with a built-in power supply and multimeter. There's my favourite instrument here. This is the differential input isolated BWD power scope. This will allow me to simultaneously measure 4 signals completely isolated from each other and get the timings of those signals. So that means I'll be able to do the transmit and receive coils, but also the circuitry within the machine, and to see what sort of delays there are, or what sort of propagations required in these signals, and what they're allowing for. I also have started pulling this one apart as well. This is the 14-inch Minelab coil, and I've got the same future as this one. It's going to be completely pulled apart, and from the findings there and also through calculations, I'll be making a coil the size of a Sadie coil for the GPZ, and we'll see how it goes. Of course, I'm like I said, I'm just only learning, and this is my first foray into detector coils, but I think we'll do okay. Okay, I'm prepared to do the tests and trials and try these different ideas, and you know, this is not a PI detector, strictly speaking. This is actually a 0-volt detector. So it's a ZVT technology that was developed for the 7000. So it is very different from the earlier ones, the early PIs, and the location of the coils and the orientation, how they are. You know, you've got these two D-shaped coils either side, and they're in opposite directions, so they're effectively a figure 8. So they've got a nulling function, so that when this thing's transmitting, it's not affecting the receive coils. But they have to be tuned, and they have to be tuned very, very accurately. So the relationship between the impedance of this coil and the impedance of this coil is critical. And as you saw in the early videos, there was a marking here showing some readings that were taken during manufacture. I've taken the readings on this, but I won't reveal them at the moment. They are different from what was on the tape. So I had one viewer who sent a very nice comment. So if you want to have a look at what that viewer has said, I've marked him for a favourite, so he should be near the top of the list on the previous video. And he had some further insight into these coils, which I've taken on board to make sure that we're heading in the right direction. So I hope at some stage I'll have the mould, which I'm going to 3D print out of PET to allow me to vacuum form and create ABS covers for whatever I come up with in the end. So there you go. The other thing I want to do is make a really big coil, a bigger one than this, but lightweight, as lightweight as it can be with this much copper in it. but we'll make it so that it works properly, not like this thing. And that would be good to see how a really big coil goes in the 7000 as well. So there you go. So that's where we're heading. So we've got all the gear, we've got the motivation, and we've got the time. So I'll see you in the next one. Like I said, this is just a little taster for where we're going, and we'll talk soon. Have a great day.